Hello and welcome back to iPio's programming channel. Let's tackle the decimal system. That's a big one. So, decimal. You've got numbers 0, 1. Oh, that's a 9. 0. I should also write it as a comment so the compiler doesn't freak out. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's all the numbers you get. You don't get to have anything else in the decimal system. Okay, that's not true. You have plus, you have minus, you can have dots or like comma. Let's go dots. Plus, minus, those. I guess you could go for E or E and go plus, minus, and then another number. I think that covers everything that we could do in decimals. Okay, let's write a decimal number. Like a decimal number, is it an integer decimal or is it not that's a question that I'm asking myself. What does someone refer to when they say it's the decimal system? Do they include only integers? Start with integers. Okay, an integer, you can have any of these numbers. Is it too big for an integer? Okay, yes, in programming, things are fit into boxes or they don't. Integer max value. Oh, it's 2, 1. I actually want to copy that. So let's go right click and navigate. Peak definition should be okay. Let's copy that out of here. So we can't have a number bigger than that inside the integer data type. We can go for long. Long L equals long.max value. And the max value for long is this one, this fellow human long value. We don't get to have an int 268, right? That's not a thing. No, it isn't. Okay. If you need that, do we have big num naturally or something? Big num? No. There's a thing called big number, because technically, if you know the decimal system well enough, you can make your own math. So you can go and have a bigger value than that by putting it into a string. See? So you can have bigger values, you just don't get the comfort. Also, you have unsigned variations. Unsigned, unsafe, unsigned. Is it oolong? Yeah. Ool equals oolong dot max value. That's also an option. No, go to peak definition. That should be a fairly big one. So this is the biggest number you can have. Let's rename this one so they match. Yeah, see, way bigger. It's not random that this looks like it's roughly 2 times as big. It's not exactly 2 times, because if you look, 7 times 2 would be 14, but this one ends in a 5. That's because of the difference, plus minus 1 that you get through 2's complements. Okay, not that important right now because we're on the decimal system. So these are all the numbers that you get. If you add 2 decimals, get a different decimal. Decimal number. If you adding, subtracting, multiplication, it's all okay. If you multiply 2 long numbers, well, long result is long A times long B. actually interesting. I have never thought of that because it's not a real use case. But technically, if I multiply these two values, it should be insane. Like, that's not. Let's look. Console.writeLine. Yeah, just output this value, please. It's 1. Yeah. And the reason is that this just overflows wildly. Like, if you basically you think of multiplication as adding the values, right? Just like in school, I guess, in elementary school. The first time you learned multiplication, it was like 1 plus 1 plus 1. Well, that's 3 times 1. That's the same thing here. Just the computer does it the other way around. He goes multiplication is way too complicated. I'm going to add everything. There are processors who have specific multiplication cores, but there's always the fallback of adding things up. 64-bit math is actually not that easy, and especially for other languages like C++, if you multiply two 64-bit values, this might not compile depending on which platform you're on, so or for which platform you compile and which libraries you have. So you might have to resort to do the addition yourself, but that's also super specific. Yeah, so you can think of that as adding, and if you add to the biggest number 1, you get the lowest number. If it is an unsigned and you added 1, you get to 0. If it is signed, you get to something minus. So it's not surprising that this is just a wild value, and it's not useful to bank on that for anything. So if you have multiplications like that, long it's just not the data type for you. And that's the limitations of the decimal system on your computer. So what are the others that I wrote down? Like plus minus in front of a number, pretty straightforward. Double, actually I think long double is a thing, right? I don't need to write new. Okay, no, long double isn't a thing here. Okay, sometimes it is. Some languages. Double 2, 3, 4. Now I just used an integer and I write it into a double. It'll be treated like a double, and to some extent there's actually no loss of information. It's only if these numbers get either very big or if they have a lot of digits at the end, like if they're very precise or very big, so have a lot of significant digits and that span a long distance. This is where you run into trouble. But for like normal numbers, it's okay. You can express 100 like that, or you can express 100 by writing 1 times 10 to the power of 2. 10 to the power of 2 is 10 times 10, that's 100, and then 1 times 100 is 100. So, and 10 to the power of is like this exponent thing. Exponent plus 2. That's 100 right there. And you can write, you cannot write 2.2 as an exponent. That makes no sense. He not accepted. You don't get to do that. You can do that in math. This isn't math. 1e plus 2 can also go e minus 2. You can't go e2, I think. No, it just accepts it. Okay, he accepts it. He assumes 2 then. I'm pretty sure of that. You can go 1.1 e plus 2 plus 6 if you like. This is just the amount of zeros that you want to kind of add or multiply with. You want to shift it by these amount of zeros. Yeah, and that's the decimal system as we know and love it. Nothing else to add here. It's been 10 minutes. I wasted 10 minutes of your life, and I'm sorry. We're going to go into the hexadecimal system in the next video. Thank you so much for watching. See you next time. Bye.